Hi everyone, thanks for joining me. Today we're going to be talking about OpenGL. So as you learned in the previous video, I'm trying to create some fluid simulations, and there are multiple ways to go about this, but I decided that I want to try to use OpenGL. It's something that I've wanted to experiment with for a while, and this seemed like a good opportunity to do that. We don't have any actual fluid simulations yet, but I will be walking you through kind of my progress through what I've learned over the past week or so of trying to use OpenGL. So let's get right to it. So first of all, what exactly is OpenGL? Well, it's a graphics API, which stands for Application Programming Interface. Essentially, an API allows you to call functions that do certain things. And in this case, since it's a graphics API, OpenGL allows you to call functions that do graphics things with your GPU. And it's worth mentioning that there are multiple different APIs that allow you to do this. OpenGL is just one of them. There are pros and cons to each of these, but I won't get too deep into that today. So how exactly does this work? Do you download OpenGL and use it like that? No, not really. As I mentioned earlier, OpenGL is a graphics API that allows you to access your graphics card and do certain things with it. And so it's entirely dependent on what graphics card you have. OpenGL doesn't actually implement any of the functions, it just has a specification for these different functions that you can access within your graphics card. So each GPU manufacturer has their own implementation of OpenGL functions. Whatever GPU you have, it's the drivers for that GPU that contain the manufacturer's implementation for OpenGL functions. This means that each driver's implementation of OpenGL is actually going to look a little bit different. One thing that OpenGL does have going for it is that it's completely cross-platform, because it's just a specification that all GPU manufacturers have to follow. Every single GPU manufacturer will have some implementation of OpenGL functions. And so whenever you write OpenGL code, you can be pretty sure that it'll work on different machines, on multiple different machines. This makes it especially easy for, say, smaller game developers to write OpenGL code and be sure that it'll work on, say, Windows, Mac, Linux, etc. With that out of the way, let's try to do a thing. So I guess just for like the kind of basic environment that I'm using, I'm going to be using Microsoft Visual Studio. And then on top of that, I'm also going to be using two different libraries just to kind of start us out here. And these libraries are GLFW and Glue. So let me first start by talking about GLFW. Essentially, this is a library that allows us to more easily create OpenGL cross-platform windows for us to, visualize what we're doing. And Glue is another OpenGL library that allows us to access more modern OpenGL functions on our GPU drivers more easily. So let's just go ahead and try to get set up here. Here's the GLFW website that kind of allows us to download the GLFW source code, or you can get the binaries. So you can see, you can get the source code here, and this would be good if you were trying to do something a little more complicated with that. But for our purposes, this kind of just Windows binaries is good enough for me, so that's what we're gonna do. And over here, we can see this is the Glue website. And through this, we can, same as with GLFW, you can either get the source code if you want, or you can just get the Windows binaries. So again, I don't really feel the need to use the source code because we're just trying to get something up and running quickly. So instead, we're just going to go ahead and get the binaries, and we're going to use that to kind of link it into our Visual Studio project and get that up and running as quickly as possible. Okay, so I've already gone ahead and set stuff up here and kind of got stuff going, but let me just kind of walk you through what I did whenever I kind of already downloaded all of the binaries and whatnot. So if you go here, you can right click on your solution directory and then click on properties. And here you can go into these different options and change any dependencies that you need to consider. So here you can see that we've included GLFW and Glue dependencies. For the C++ additional directories, it's also worth mentioning you need to make sure you're on all configurations here, because if you have it on release or debug, then that could cause some issues. And also make sure that it's the correct platform for whatever you're using. You'll also notice here that I use solution directory, so this is just saying that this is from our solution directory. I created a dependencies folder where I put any of the stuff that I was using. So in this case, it was glfw and glue, and then just put the include stuff here. In the linker as well here, I put, in general, you can see additional library directories. So this is the same for glfw and for glue. And also in the input for our linker, this is just any additional dependencies that glfw or glue has that we need to pay attention to. A lot of this can be found whenever you try to build your project after putting the other stuff, and it'll say like, hey, we don't have this thing, and you can look, oh, what is this thing? And then you can find it and include it here in the additional dependencies. So whenever we're doing stuff in OpenGL, there are two main things that we need to pay attention to. These include vertex buffers and shaders. So a vertex buffer is really just a buffer. It's a chunk of memory that exists that contains some set amount of data, some bytes. What makes vertex buffers in particular different is that it's a buffer that exists in OpenGL. So it exists on our GPU, on our video RAM. And so essentially this allows us to kind of read in our data from the VRAM and interpret it in some way. This is where shaders come in. So a shader is really just a program that tells the GPU how to read and interpret some chunk of data that we have that exists in our vertex buffer that's in the video RAM. And that's really the basis of what we need to know about shaders and vertex buffers. Essentially, it just allows us to store whatever we're trying to draw on the screen, and then whenever we have our shader, it will specify how we should read this data, how we should interpret it, and how exactly we want that to show up on the screen. Okay, so let me go ahead and start by just kind of walking you guys through what we have here. And yeah, don't really expect to be blown away. This isn't anything amazing or crazy or out of the ordinary. But essentially all we're doing is we're just trying to draw a triangle. And we're doing this with OpenGL, using these OpenGL functions with glfw and glue. So let me just kind of run this real quick so you guys can see what the final product looks like. And here it is. It's just a triangle. But I will go ahead and walk you through kind of generally how we created this triangle, because there's a decent amount that goes into this stuff. So as I mentioned earlier, vertex buffers and shaders are really the most important things that we're going to be focusing on here. The glfw window itself that shows up is actually, it's just taken from the glfw documentation. Here they just have some basic example code for creating a glfw window, and I just kind of used this basic base to set up our glfw window. And it's actually a great way to test to make sure that glfw is working correctly whenever you first put it inside of your project. So this glfw window, this is the window that shows up, and whatever is inside this while loop, it gets rendered every frame. So I went ahead, our buffer is actually defined outside of this loop because it's just going to be this static thing, in this case a triangle. But if you, say, wanted to update the buffer every frame or so, then you would just put the buffer inside of this while loop and you would be updating it every time, right? And so this will actually probably be very useful whenever we are doing our fluid stuff, our fluid simulations, because this will allow us to update the buffer every time that we go through, and we can change how it looks every frame. Here is our create shader function, and you can see it takes a string for both a vertex and a fragment shader. So these are just different kinds of shaders. I won't get into that today. And so you could just kind of write in here, have something defined, where inside of here you're writing all of your code for the vertex or fragment shaders. But that's obviously, it definitely could work, but it's just a little bit not so great. It's a little frustrating to do that way. So here you can see on the side here, I've kind of organized it like this, resources, and then we have the shader folder, and then here we have our application. So if you come over here, this is actually where I defined our vertex and our fragment shaders. And so this vertex shader tells us these are the positions, and then this fragment shader we use to define the color of our triangle. So you can see here color, and then we have these 4 numbers. So what are these 4 numbers? You could probably guess this is RGBA. So if you're used to like the 255 system, you can just imagine that 0 is just the 0, and then 1 is 255, and then we have all of these just decimal points in between. So here you can see, and I mean you saw earlier, it was just kind of a kind of reddish orange, I guess, color for our triangle. And that's really all it is. If you want it to be blue, green, whatever, you can just change the colors accordingly to whatever you want. And yeah, I mean, that's really what we have. This here verifies what the different type is that we're working with. And this just kind of looks through this shader and it reads this file. Actually, whenever we create our window, we're just going to be giving it our buffer and our shader, and it'll just kind of load it in and just show it on the screen. And that's pretty much what we have. It's nothing too crazy. We also did create some basic stuff to tell us whenever something went wrong here, whenever we compile our shaders, and telling us which one was wrong, so we can look at like if something went wrong. But yeah, nothing too crazy. And that's really all we have. So I guess we can kind of follow along to see where this goes. I know that it seems like we didn't really have a whole lot today, but I promise this stuff actually takes a little bit of time to set up. And I'm glad that we are starting with something a little more simple, just a triangle to start out with learning OpenGL. And from this, we can kind of extrapolate it a little bit more as we continue on, and we can use that to create our fluid simulations later on. So now that we have everything set up, I think this should give us a really good foundation to continue experimenting a little bit more with OpenGL, and once we're a little bit more comfortable with it, then we can try to use what we have set up to create those kinds of OpenGL fluid simulations like I talked about earlier. And we'll just kind of see where that goes. Thanks so much for watching. Hope you have a great day, and I'll see you guys in the next video.